Hello, this is the 2012 Oxford Maths. So I'm going to start off in this video with the multiple choice questions. Question A, which of the following lines is a tangent to the circle with equation x squared plus y squared equals 4? So we're only going to get one solution then, is what we want with a tangent when we solve these simultaneously. So I think we'll just start plugging some in, shall we? So x plus y, so y is equal to 2 minus x, stick that into there, x squared plus, well, we've got to square this thing, so that'll be another x squared minus 4x plus 4 is equal to 4. Now cancel the 4's, and then we've got, well, we can cancel some 2's, so we've got an x squared minus 2x, so an x minus 2 equals 0. So that's got multiple solutions, so it can't be a tangent. We can just keep doing this. So, okay, let's go again. So square this thing. We've got an x squared, we've got an 8, and we've got a minus 4 root 2x. Then we've got to add on our initial x squared, so that's equal to 4. Take that off to make it a 4. Divide everything by 2. X squared minus 2 root 2x plus 2 is 0. Now b squared minus 4ac is going to be 8 minus 8. So this is looking good. So b is going to be our answer. Depends how much we trust that we've done that. I've actually done this correctly. If x was root 2, what would we get? We'd get that y squared is 2, so that would have two solutions. This one would give us an x squared plus 2 minus 2 root 2x, add another x squared, that's equal to 4, so get rid of all these 2's and make that a 2 on the other side. So x squared minus root 2x minus 1 is 0. B squared is 2 minus 4ac, so we'll be adding on 4, so that doesn't work either. Right, so yeah, a sort of clunky starter, but at least it was easy enough to do. Question B, let n equal all of this, 2 to the k times 4 to the m times 8 to the n. K, m and n are positive whole numbers. Right, that helps. N will definitely be a square number whenever which one of these conditions applies. Okay, definitely a square. It doesn't say it will only be a square for a particular one of these conditions. So we've got a sort of limited proof we have to do on this. How are we going to get this together? I mean, they're pointing us towards making this one number by having all of these 2's and powers of 2's there. So that'd be 2 to the k times 2 to the 2m times 2 to the 3n. So 2 to the k plus 2m plus 3n. And we want this to definitely be a square. But that's definitely going to be a square when this power is a multiple of 2. Because you could write that as, say, 2 to the y squared if this thing is a multiple of 2. So we want k plus 2m plus 3n to be a multiple of 2. So we want 3n plus k to be a multiple of 2, because m's fine. Yeah, we want these to be even. 3n plus k to be even. So what are we doing? K plus n is even, k plus n is odd. So, well, actually, we can split that, can't we? 2n plus n plus k. So we just need n plus k to be even. Which, oh, right, that's d. Right, okay, so that kind of dropped out. A little bit unclear where it was going, but it dropped out okay. C, which is the smallest of the following numbers? Okay, root 3 cubed, so 3 root 3. Oh, let's just leave that where it is for the moment. Log to base 3 of 9 squared, so that's going to be 4. 3 sine pi over 3. Sine pi by 3 is root 3 over 2. So 3 root 3 divided by 2, then squared. So that's 27 over 4. And that is much bigger than 4. So it's not going to be that one. Actually, let's compare these two. 3 root 3 is bigger than 4. Then we got D, log base 2 of log base 2, 8 to the power 5. So log base 2 of 8 to the power 5 is 5 log base 2 of 8, which is 5 times 3. So that's log base 2 of 15. That's less than 4, because log base 2 of 16 is 4. So it's not going to be that. It's going to be D. Question D. Shown below is a diagram of a square with vertices 0, 1, 1, 0, 0, 0, 1, 1, 1, 1, 0. Right, a unit square. Right, I could have said that. The line y equals x plus c. It is there. The shaded region is the region of the square which lies below the line. Okay, that's got area A function of C. So C is varying around. Which of the following graphs shows A as C varies? Okay, right, so they're 4 very different graphs. So let's start in the middle then. If C's 0, we're going straight through here. We're getting half a square. So in C's 0, we want a half. So it's not D. That's good. So what happens as C varies from 0? Well, we're getting bigger changes in area closer to C is 0 than we are over here. So we're going to want a steep gradient there, shallowing off on either side. So, oh, right, well, that's A. Right, so they haven't made us do much work for that. That was fine. E, which of the following equations could possibly have the graph given below? Right, so this graph then, so we've got repeated root, then we've got a root. So this is going to be a negative x to the 5 graph. So which ones of these are negative x to the 5 graphs? Well, they're all x to the 5. This one is positive, positive, negative. So that one's negative. This is, well, we've got a negative overall here of a positive. So that one's negative. This is positive, positive, positive. So it's not C. That's a positive x to the 5. And then that one's negative as well. Okay. What else have we got? So we've got when x is 0, we want a positive value for y. So here we would get positive, positive, positive. So it could be A. Could it be B? We're going to get A. No, we're going to get 0. So it isn't B. And for D, we're getting positive, positive. So it could still be D. So it's got to be the roots then, which are determining what's going on here. So these roots we've got repeated at 3 and minus 3, and then we've got a root at 1. Right, so that's definitely not it. So it's going to have to be D, which has got minus 1 and 1 repeated roots, and then another root at 3. Right, excellent. So it's D. That was a nice question. F, let T equal this horrible looking thing of 3 integrals multiplied together. Which of the following is true? Is T 0, negative, positive, or not defined? So we've got an integral of cos x between minus pi by 2 and pi by 2. So that is our cos x between those. So that's some positive area. Sin x between pi and 2 pi. So that would be some negative area. Integral of something to do with cos between 0 and pi by 8. So somewhere in this region. So that's going to be positive as well. So it's going to be negative all in all. So that is B. Right, that was easier than it looks as though it was going to be. G, there are positive real numbers, x and y, which solve these equations. Okay, so we need to be able to solve these for what values of k? Right. Right, yeah, so it suggests I'm tempted by this C of putting 2 in and then seeing, because that's going to rule out a lot of options, isn't it? Can we just pick our way through to an answer? Let's see what it's like actually combining them. I reckon get rid of x so we don't get a k squared in this. So x is k minus y. So we've got 2k minus 2y plus ky equals 4. So that is y k minus 2 equals 4 minus 2k, which is 2 minus k. Oh, right, okay. Even better, we can get these k2s off of here. So we can say that is minus 2 k minus 2. So we've got y k minus 2 is minus 2 k minus 2. So we're getting solutions here for y equals minus 2 or k equals 2. So it's certainly not that. It's certainly not that. Oh, we can't have, they're positive. It's positive real numbers, x and y. So we can't have that. So we've got to have k is equal to 2. So it's got to be C. But I reckon you could have picked through, because if you put k is 2 in here and then you solve it, which we must be able to get, I'm just intrigued as to how quickly 2x plus 2y equals 4, x plus y equals 2. So that's just, well, yes, it clearly does work. So that would have ruled out B. Does it work for all values of k? So say usual thing is try out something really weird, like a huge negative number or a huge positive number. So say we had k was, well, it's not going to be this thing as well, is it? Only for k is greater than the, yeah, well, if k was 0, then that isn't going to work either, is it? Because we'd have 2x is equal to 4, and x, oh no, you could have x plus y is equal to, oh no, you still couldn't, because they got to be positive. So you'd have to have x and y as 0, so that doesn't work either. So you could just pick through with numbers on that one. Although solving it, I mean, that's the better mathematical way of doing it, you know, not relying on the fact that it's a multiple choice question. Okay, H, in the region 0 to 2 pi, including 2 pi, but not including 0, the equation, the integral of sine t dt. Wow, has no solution, one solution, two solutions, three solutions, for that being equal to 0. Right, where to go on this? Integral of sine t dt. So what is that even going to look like? Because I don't know how to integrate it. So we're going maximum, we're going up to 2 pi for x up here. That's our maximum. Okay, so, well, sine clearly looks like, well, okay, that went a bit, pen got a bit carried away there, but that's our sine of something, sine t. So if we were doing sine of sine t, so that's our pi and that's our 2 pi, sine of sine t. So we're doing the sine of some positive number. So it's going 1, 0, minus 1. The sine of some number between 0 and 1 is going to go off to be some kind of positive thing, positive curve, after we've signed it again. So if we do the sine of some negative number between 0 and 1, that's going to go off to be some negative curve, which is the negative of the positive curve. So these are the same curves through symmetry, but one's positive and one's negative. And we want to add those up in order to make them equal to 0. Well, the only way we're going to do that is if x is 2 pi. That's the only way we're going to do it, is if we include the whole lot, because otherwise we're going to be building up some positive area as we go up to pi. So that's going to mean it's greater than 0 all the way through here. And then we're going to start removing area, but we only remove the whole amount of area that we added when x gets up to 2 pi. So it's going to have to be b. It's going to have to be one solution. It's all we got left. Right, that's another really nice question. Right, 2 to go. So question I, the vertices of an equilateral triangle are labelled x, y, and z. The points x, y, and z lie on the circle of circumference 10 units. Let P and A be the numerical values of the perimeter and the area. Which of the following is true? Right, okay, so a little picture will help with this. So we've got our slightly wonky circle, we've got an equilateral triangle, and we're saying, what are we saying? So the radius, no, the circumference is 10 units. So let's mark on an R then. So 10 is equal to 2 pi R. Then we've got that our perimeter of the triangle, so let's call that side x, so 3x, and we got our area is going to be, well, half base times height, so x over 2. Then, well, actually, let's do it off of this. So if that's 60 degrees, we can say it's a half AB sine C. So it'd be a half x squared times root 3 over 2. So x squared root 3 over 4 is our area. Okay, we need a relationship between x and r, and we've certainly got a relationship between x and r. So let's take that one first of all. So r is going to be 5 over pi. So that's a start. But then we've got these little triangles here. So x over 2 is r cos 30. X over 2 is r cos 30 is root 3 over 2. So r root 3 is x. Right, okay, so that gives us x equals r root 3. So P Oh, wow. Okay, let's get this as r is 5 over pi. So that's 5 root 3 over pi. That's what x is. So p then is 15 root 3 divided by pi. Our area, x squared, so it's 25 times 3. So if you've got 75, then we've got a root 3. So that's the top. And then we're going to have a 4 pi squared on the bottom. Wowzers. Right. So which one of these? These aren't even nice options that we've got here. Well, it's not D. P squared is not rational because I have a pi squared on the denominator. So we can get rid of that. But I think we're going to have to, I mean, it's not even obvious just glancing at them. Actually, or is it going to be obvious? Is P less than A? Because we've got these pi root 3s that we can, and root 3s we can get rid of here. Right, so let's do, well, this will come out, this is really saying is P over A less than 1. That's what we've got on that one. So we want to do a ratio of these. We want to do A over P or P over A. It's annoying they've put them other ways up. But I'll start with A over P just because it's the first one that's on the list. So A over P, so we've got 75 root 3 over 4 pi squared. And then we'll be multiplying by pi over 15 root 3. So we can cancel the root 3s, cancel what pi's. 15's in 75 is 5. So get rid of those. So that comes out as 5 over 4 pi, which is A. Oh, right, okay. So we hit lucky with it being the first one on the list. But I suppose it's not hard to then, that's just that upside down. So that's clearly not right. And then that would be this thing upside down. Is it less than 1? 4 pi over 5 is not less than 1. So yeah, A. Right, that was a really fiddly question. J, and we've got more geometry, which is good. If two chords QP and RP, okay, on a circle of radius 1 meet at an angle theta at P, right, for example like this, the largest possible area of the shaded region. Largest possible area is what? Well, we're going to get largest possible area when this has moved round to be in the middle. We want it to be symmetrical about P, because that's always when you get largest possible area. So we want PR to be equal to PQ. So how is that going to help? Let's draw a new picture then. So we're going to have we're going to have this going on. That's the area that we want to work out. That is theta. That is some length x. That's some length x. And then we've got these lengths here are all, these are all radiuses. So we've got a radius, a radius, a radius. That's the center. That's the point there. Yeah, so this is going to have to be what we're joining. Essentially we're drawing that, but making it symmetrical. Oh, wow. So, okay, right. So it makes it easier seeing the circle on there. This is a GCSE circle theorem. That's going to be 2 theta then. So we've got 2 theta there. So we've got a sector and we've got this dot. So we can split it that way then. So this is a circle of radius 1. So the area of this sector is going to be pi r squared. So that's pi multiplied by 2 theta divided by 2 pi. So cancel, 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 cancel. So we've got theta is the area of that bit. So we want a theta in our answer, and then we're adding on a bit more. So it's not going to be that. So it's looking like A or B, because C doesn't just have a straight theta in it. And then we've got these 2 triangles. So these triangles then are going to be, what is this triangle? We've got that. That's a radius. That's a radius. Oh, and they're radius 1. So that's 1. That's 1. Then we've got, that is going to be angle theta over 2. That's going to be theta over 2. So we've got that, which is going to be pi minus, not equals, pi minus theta is our angle here. So the area of this is going to be a half AB sine this. And then we've got 2 of them. So we want to do AB is 1. And then we're going to have sine of pi minus theta, which is equal to sine theta. So it comes out as B. All right, that was probably the best 1 out of 10, I would say. That drops out really nicely once you get this symmetry thing, because if it's not when it's in the middle, you think, I mean, you can see that it's small over here. If you move it all the way round, you're just making the area smaller and smaller, so it's increasing as you go this way. There's nothing about this, because Q and R are completely interchangeable. It's got all this symmetry about it. You're not going to get 2 maximum points. It's got to be when you get to the middle that you get 1 maximum area. So same old thing. Whenever you can just interchange 2 things, you know, Q and R, there's nothing distinguishing them whatsoever in this picture. You can just change them around. So we must have symmetry in the line dividing those 2. Right, that was an interesting bunch. I really liked J. It was fine. It was just a bit hard work. That one was really nice, H, for thinking it through. So that was a good question. G wasn't too bad. That was nice, F. E was really nice. These were good questions. Okay, that was a bit of a gimme for D, but I suppose there was a lot to read for D. C was nice. B, actually, it was a good bunch. A couple of them just felt a bit sort of algebra clunky, maybe, that perhaps there was a quicker way of sorting them out, because the algebra was clunky enough. I think there were 3 of the questions I was thinking of, well, maybe I just want to try out the answers and do a shortcut rather than going through the algebra. It's not like the algebra took ages, but a little bit longer than maybe on some of the previous papers. But overall, this had some gems of questions for the first part. So a nice start to this paper.